Okay, welcome, boys and girls. We are going to be beginning Unit 10. Unit 10. Unit 10 is an exciting chapter in which we are, in essence, kind of making decisions about things. We're testing claims. And so whenever I kick this unit off, I always think of, like those crazy commercials that you see every now and then that are just stating something that is absolutely ridiculous. If you buy this golf ball, you'll be able to hit the ball further. If you buy this pair of shoes, it'll make you run faster. If you buy this toothpaste, it'll make your teeth whiter, and those sort of things. Those claims that, well, they might be true, they might be false, I'm not sure, but it's one of those things where if there was only a way that you could actually prove that or disprove that, that would be handy. Well, that is exactly what we're going to be kind of talking about in this chapter. Is we are going to be talking about these claims, and we're going to see that, yes, there is a difference, that this product does work, or no, they're full of it, this product does not work, and there isn't a difference being created by the old brand of toothpaste or whatever. So again, you're probably not going to understand everything that we're going to be talking about right here up front. But again, practice, practice, practice. You'll kind of get the hang of it, and you'll see. Hopefully, it'll become second nature to you about how to do a lot of these things. Okay. So let's go ahead and take a look at the problem that we have before us here. And here again, we have a claim. We have a punter, like in football. Punter, a punting shoe. Okay? So if you buy this new shoe, it'll help you kick the ball further. And so what we did is we tested this. We got 9 different punters in this case, and they kicked the ball with the new shoe, and then they kicked the ball with the regular shoe. And so we see, okay, the new shoe worked in this case. We kicked the ball, 6 yards further. Wow, this guy can boom it. And then we have all these different punters. And we're going to see, does this new shoe work? All right. Now, to test this claim, we're going to see some new variables being involved with some of these problems here. And so let me kind of introduce you to some of these things and how we get this ball rolling. Okay, first and foremost, we're going to be introduced to this new variable D. All right, D stands for the word difference. Difference. There's a difference, which is subtraction. And the difference that we're going to establish is what is the difference between the new shoe and the regular shoe. So that's going to be x1 minus x2. All right, so how to begin this problem is what I really encourage you to do is to take x1 and make that list 1, and x2 and make that list 2. So if I'm going to be making this difference in calculator speak, that is going to be list 1 minus list 2. And that will come up with the difference. It's going to be a list. And so what we're going to do is we're going to store that as list 3. We're going to store that as list 3. So let's go ahead and do that and make sure we know how to use our calculator. I know it's probably been a while since we use these lists and how to store things. So let's go ahead and talk about some of these aspects of our calculator. So we go to our stats, we clear things out if we need to, and then we're going to enter the new shoe as list 1. All right, so I'm going to scroll through that just to make sure I didn't hit a silly button slip. I do all the time. Okay, looks like I'm good with that. I go over to list 2 and I enter the regular shoe. Whoa. Again, arrow through that, make sure you didn't make a mistake. If you did make a mistake, that's not a big deal. Obviously make sure you correct it. What's really vitally important, though, is that you don't mess up the order of these numbers. Like, so 63 has to match up with 57. 101 has to match up with 94. So you can't, don't mess up the order in which these numbers come. It's really vitally important that the 1 corresponds to 2. Okay, so it looks like we're good to go. So let's go ahead and get our difference, D. So I go to the main calculator, and I take list 1, and I subtract list 2, x1 minus x2. Boom. Okay, and it's going to give you a list. This is the letter D. So what I'm going to do is I'm going to take that list answer and store it as list 3. So that's how you store the letter D. You take that list answer and you store it as list 3. Okay, so that is now in your calculator as list 3. So those are all the differences right there of each individual. So the first punter kicked the new shoe 6 yards further. Second one, 7 yards further. Third one, 8 yards further. Things like that. Okay, next variable that we need to get and use in these problems is D bar, which is the average of those differences. The average of those differences. And so we have a list of these differences, so we're going to add them up and divide by the number of numbers. In this case, that is 9. So again, calculator speak, what this is going to be is this is going to be the sum of list 3, that's our differences, divide by, in this case, 9, because there's 9 punters. Okay, and that will get us our average difference. What I do is I store that as the letter A for average. So let's go ahead and do that. So we're going to find the average of that list. So we add them up. So we sum our list 3. So that's adding up all of those differences. Divide by the number of numbers, and that's 9. Okay, so on average, a punter kicks with the new shoe 3.2 yards further. I'm going to store that. Again, I hit this arrow button right above the on. Store that as the letter A for average. That is now D bar. So let's kind of update my calculator list here. So we have the differences. That was list 3. And we created this average difference, which was the letter A for average. Okay, now we're to a point where we can actually do the very first question that is being asked, and that is the sample standard deviation. Okay, this is a formula, so the sample standard deviation, S is equal to the sum open of D minus D bar, closed squared, closed, divided by n minus 1, square rooted. Okay, that's the formula for that one right there. Okay, how to get this on a calculator. Okay, what I'm going to first do is I'm going to worry about the numerator of this fraction. So, but again, I just pretty much turn it from math type into calculator type. So that's going to be the sum, open, D, which is list 3, minus D bar, which we stored as the letter A, closed, squared, closed. Okay, that's how I start that process, is I get that numerator. Sum, open, D minus D bar, closed, squared, closed. Again, symbol by symbol, I just type it in my calculator. So sum, open, D minus D bar, closed, squared, closed. All right, now I'm going to complete this fraction. So I need to divide that by the denominator. So I need to take that answer and divide by n minus 1. And so in that case, that is 8. Again, n is the total number of numbers in the list, 9. So divide that by 8. So take that answer and divide by 8. So that is the complete inside fraction. Okay, now the next thing that I obviously need to do is I need to square root that entire thing. So I square root that answer. And ta-da! That should be your sample standard deviation. I do need to use this in future calculations, so I'm going to take that answer and store it as the letter x. So I'm going to take that answer and store it as the letter x. Okay, that is how you get your sample standard deviation. Just follow the formula. Again, the fraction is pretty involved, so you probably want to break it down into more manageable pieces. Don't forget to actually write down the answer. Okay, that is now the letter S. So S is now the letter S in my calculator. All right, find the sample test statistic, T. So again, here's a new formula. This is going to be D bar divided by S divided by the root of N. Okay, pretty straightforward. The only thing is if you have a cool calculator which allows you to do fractions, this shouldn't be a problem. However, you may need to have parentheses around the denominator. So I need to do this piece because I don't have a cool, awesome calculator. I need to use parentheses to distinguish the numerator from the denominator. So here's what I enter. D bar, that's my average, divided by, the denominator is S divided by the square root of N. Again, N in this case is 9. That's what I would type into my calculator. I don't need to store this or anything. I'm just going to physically look this up on the table eventually, so I don't need to store it anyplace fancy. So A divided by S divided by the root of N. Okay. Again, I know you don't really know where this is headed or how this is doing anything just yet. You're just, in essence, following these formulas. That's kind of what you need to do at first, and then you'll start to get the understanding eventually. Okay, the next question is, what are the degrees of freedom? That one's easy. Degree of freedom is always n minus 1. And so again, the total number of things in this case was 9. So 9 minus 1 is 8. The degrees of freedom is 8. Okay, here's a familiar question. Find the p-value and sketch the p-value on the sketch. Okay, that's exactly the last chapter that we did. Okay, here we have a t and a degree of freedom. So let's go ahead and do that. So our p-value. Okay, again, there's going to be a lot of work, so I draw my line so I don't mess up the area, the answer area with the work area. So here I have a t that is 2.1122 and a degree of freedom of 8. So make sure you look this up on the t table. And again, it's exactly how you did last chapter. So you're going to come up with 2 different values. So 2.1122. Again, make sure you use your t table. So we're looking at a degree of freedom of 8. It's that line right there. And I'm looking for 2.1122. And so that would fall right in between those two numbers of 1.860 and 2.306. Jot that down. So again, that would fall in between 1.860 and 2.306, in between those two. This is going to be a one-tail area, so I look to the very top, and I see that is to 0.5 to 0.25. Okay, those are my p-values. Okay, now I need to make a sketch. How do I get the specific information about this sketch? Like, is it a left tail or a right tail? What's the alpha? All of that information is given down in the next question. So you see that this is going to be a right tail, because again, it looks like it's pointing to the right. This is a right tail, and my alpha is 5%. Okay, so that's kind of what you need to know to construct this sketch, that it's a right tail, and the alpha is 5%. So let's go ahead and go with that. Okay, so here I have a p-value that is 0.05. Okay, so 0.05, you'll notice, is right on the line. Okay, so that doesn't really help us. In those situations where it falls right on the line, again, we default to the other p-value. It will lean towards the other p-value. And we see that the other p-value is 0.025, which is smaller than that alpha. So the distance from the edge is shorter. So this is going to be 0.025. And so that is distinctly shorter. That is distinctly shorter than my alpha. That falls into that rejection zone. All right, so that's one exactly from the last chapter, doing the exact same stuff. I mean, it takes a little bit different formulas to get there, but it's the same stuff right there. Okay. Now this part is similar. It's not exactly the same, but it's similar. Okay. The first thing that we want to do is draw that comparison to the p-value to the alpha and make our decision on, are we rejecting H0 or what are we doing? All right, so we begin. Okay, there's going to be a lot of writing down here in this last question. So kind of conserve space and write a little bit smaller than what you probably typically would. So your work is neat and you don't eat up all the paper that you have. Anyways, here we go. So we see that our p-value is less than our alpha. That means reject H0 and accept H1. Okay, so what does that mean? Okay, we're not going to go instantly to words right now. We have to understand what the heck we just said. Because notice up above, we didn't establish a null hypothesis or anything like that. We don't have those things. So, but they give them to us right here in the question itself. Okay, they give us those things. So in essence, take the answer that you're accepting. Okay, so I'm accepting H1. So what I'm going to do is I'm going to describe what the heck H1 is. So in the world of do not reject H0, okay, in essence, what you're going to do is you're going to start talking about H0. Okay, you're going to start talking about that. Okay, here we didn't get that answer, so we're going to talk about the answer that we are taking, which is H1. All right. So what the heck is this, and how do we decipher what the meaning of this? All right, so thought bubble time. I want you to think of this, mu sub d, as being x1 minus x2. What mu sub d is trying to describe is the average difference. So the average difference. And so how we got the difference in the first place was x1 minus x2. So think of mu of d as being x1 minus x2. Okay, that's a huge connection. So what is h1 saying? h1 is saying that x1 minus x2 is greater than 0. Okay, so what? What does that tell us? And the rest of this riddle is, in essence, falling down into the idea of just basic concept math. Right? So let me get a different color here. Okay. So the concept that we are talking about is this. Here I have two numbers, x1 minus x2, and it is quote unquote greater than 0. That means the answer is positive. Greater than 0 is a positive number. So how do I subtract two numbers and get a positive number? Okay. Long story short is that is saying that x1 has to be larger than x2. Okay, so an example is like 5 minus 3, okay, is going to get an answer of positive 2, aka it's a positive number. So x1 is bigger than x2. Okay. In the situation that it is less than 0, the answer is negative. Okay, that would say that this is the small number and this is the large number. Okay, that would be the situation now. Okay, and then we'll talk about e is equal to 0 in a moment. Long story short, here's how you can adjust this statement. Here we have x1, x2. Yeah, it's disjointed. And this is greater than symbol right here. And I'm going to ignore the minus and the 0 for a second. When this is the situation, and you come up with this statement right here, what I want you to do is just take these numbers and slide them over. So x1 is greater than x2. That's what these statements are going to be producing. So x1 is greater than x2. That is the official mathematical quantification of this. All right, so what are all the different alternatives that we could potentially have? So we said x1 minus x2 is greater than 0. So that means x1 is greater than x2. Simple, easy peasy. We could have x1 minus x2 is less than 0. So that means x1 is less than x2. Easy peasy. We could have x1 minus x2 is equal to 0. So that means x1 is equal to x2. Easy peasy. We could have x1 minus x2 is not equal to 0. That means x1 is not equal to x2. Easy peasy. So what I'm saying is you're going to come up with a statement that looks something like this, and then all you got to do is just slide those things over. So x1 is greater than x2, or x1 is less than x2, or something like that. And so the key concept is to make all of this tick, you have to know that mu of d is equal to x1 minus x2. Okay, so here we go. So we're still working on this question. Now, so we make this p-value to alpha comparison, getting our what would be our answer. And so we are accepting h1. So h1 is inevitably saying x1 is greater than x2. Okay, now I need to give an interpretation of these results. What is this saying? All right, so this result told us that. What is this result physically saying? Okay, so I need to know what the heck x1 and x2 are. x1 is the new shoes punt distance. x2 is the regular shoes punt distance. So I need to say x1 is greater than x2 in physical words. So x1 is So x1 is greater than x2. So the punt distance, I described what we're talking about. The punt distance, x1 is greater than x2. So again, you have to have the stuff that is written in red there. So in this situation, yes, their claim that the shoe company is not lying to you. Their advertisements are true. The shoe does allow you to kick a ball further. Good for them. Okay, let's go ahead and take a look at the second question. Here we're looking at plant fertilizer. Does fertilizer make the plant grow larger or whatever? All right, so again, all of the formulas that you need to know. Difference is x1 minus x2. D bar is the average, so that's the sum of the differences divided by the number of numbers. Sample standard deviation, S, is going to be equal to the sum of D minus D bar, closed squared closed, divided by n minus 1 square rooted. That's a big one. T is going to be D bar divided by S divided by the root of n. I think that's pretty much all you need to know. You also need to know a degree of freedom, but that one's easy peasy. It's not a big deal. All right, so think about how you can use calculator speak. How can you use your calculator to make this stuff easier? All right, so how I begin this endeavor is I make x1 my list 1. And I make my x2 my list 2. And then I start storing things into my calculator from here. So let's go ahead and set this up and let's start working. Clear everything out so we don't get things confused. Okay, scroll through that, make sure I didn't make a silly button slip. Again, I do it all the time. Okay, we're good to go. All right, again, scroll through. Now, again, when you're doing these actual calculations at home and doing these on your assignments and things like that, without fail, you're going to come up with an error message on your calculator. All right, I'll give you an example of what this might look like. So I'll go like list 1 minus list 2, and your calculator is going to go. All right, it's going to say, no, that's not okay. Dimension error, beep, bop, boop, beep. All right, so your calculator blows up. Now, inevitably, this is going to happen. Okay, so with my experience, why this is usually happening, is because something is wrong with your lists itself. Either you have an extra number, or you have too few of numbers, you missed a number somewhere. Something is wrong with your lists itself, especially when they say the dimension error. They're saying the two lists are of unequal size. Like one has 12 numbers, the other has 11. All right? And so what you need to do is you need to go back to your lists and either re-enter them or find where the mistake was made. And so I made this happen because I purposely deleted the very last number of my second list. I should have an 11.4 there. So these lists are of the same length. And now when I go back to my calculator and I try to do my calculation, hooray, it works, and everybody is gleeful. Okay, so actually this is the very first answer that I need to do. I need to find those differences. So that's x1, which is list 1, minus x2, which is list 2. Okay, those are my differences. Again, what I do with that is I store that as the letter, as list 3. I store that list answer as list 3. So I take that list answer and store it as list 3. So that is now the letter D. I'll add that to my calculator list that I have. Okay, the next thing I need is my average, which is D bar. D bar. So that is the average of that list. So I add up all the numbers in the list D, which is list 3, and I divide by the number of numbers. In that case, it is 12. Oh, let's try that one more time. Huzzah! There it is. Okay, and that is my average. So I take that answer and I store it as the letter A for average. I try to avoid storing it as the letter D because when I see the letter D, I want to put in the letter D. But D is list 3 and then D bar, and so it's just to kind of alleviate that mess. I store it as the letter A for average. It helps my brain out. Because if you store it as the letter D, what's D? Is D D or is D bar D? And so I don't want to play that game. All right, here we go. Sample standard deviation. Let's begin with the formula. Again, what I'm going to do is I'm going to get this top answer of the inside. So that's going to be the sum open of D, which is list 3, minus D bar, which is my average, close squared closed. And then with that answer, I'm going to divide by the bottom, which is n minus 1. In this case, that's 11. Again, n is the number of pairings that you have. So n minus 1 is 11. All right, I need to square root that answer, and that is indeed going to be the letter S. And so I'll take that answer and store it as S for my sample standard deviation. Okay. So here we go. So our standard deviation in this case is 6.6908. Okay, and that is in my calculator now as the letter X. Next is the sample test statistic T, which is D bar, S divided by the root of n. So again, how I enter that into my calculator You can do it however you would like. Tell me the correct way to do it. Is d bar divided by, okay, again, I have to have the bottom in its own unique parentheses, s divided by the root of n, which in this case is 12. Okay, so this is 2.7999. The next is the degree of freedom, easy peasy, that's n minus 1. So if n is 12, this is 11. Easy money. Okay, here comes the p-value. Again, I looked down real quickly. This is a one tail, and we're going to have an alpha of 5%. It's going to be a right tail more specifically. So I don't look up a two tail, I look up a one tail, and yeah. So here we go, p-value. This is built upon a t that is equal to 2.7999, a degree of freedom of 11. So 2.7999 degree of freedom of 11. Again, make sure you actually use your t-table. Degree of freedom of 11. 2.7999 is in between those two right there. So it's in between 2.718 and 3.106. And so this is a one tail. So this is in between 0.1010 and 0.005. Those are my p-values, so I make sure they're up in my answer above that line on the answer line. Those are the p-values. All right. So okay, so what does this mean? Oh, excuse me, sketch. This is a right tail. Okay, alpha 5%. And here we have a value of 0.10005, both way smaller. All right, so that's how I begin my answer. I see that my p-value is less than my alpha. That means reject H0 and accept H1. So H1 is my answer. H1, reading up above, says mu of D is greater than 0. So that means x1 minus x2 is greater than 0. That means x1 is greater than x2. All right, so x1 and x2 are, in essence, the plant growth. I'm assuming these are plant heights. Plant growth, plant heights with and without fertilizer. So x1 is with fertilizer, x2 is without fertilizer. So I'm assuming that these are plant heights. So x1 is greater than x2. X2 is without fertilizer. So x1 plant height with fertilizer is greater than x2, plant height without fertilizer. There it is. Okay, again, we will obviously go over other examples, like how do you say things when you do not reject H naught, and how do you say that? So there's some like kind of twists with the words and things like that. So we'll obviously talk about those things in future videos and in future assignments. So stand by on that. But again, this is the new dynamic. Here are the important formulas. Get comfortable with using your calculator and storing letters in and things like that. If you're having troubles with your calculator or just doing these things in general, please ask questions in class. Please get your confusions clarified because these are vitally important to be successful in this chapter. Okay, other than that, I will see you in the next video.